In this video, I'm going to go over using interval notation. What is interval notation? It is just a different way of writing out these inequalities. Now, you know what inequalities are, I'm sure. I have examples of almost every inequality you can think of. Of course, these can be mixed and matched. Like, say, both of these could be less than or equal to, or neither of them could be less than or equal to, or maybe the one on the right could be less than or equal to, but you get the idea. All right, so what is interval notation? We're going to write all of these out in interval notation. The interval notation is, well, what is a notation? It's a note. It's the way you write something. It means the same thing over here. So what's another way of writing this but an interval notation? Well, x is some unknown number, right? Or it's a set of numbers. It's a group of numbers. It's not just one number. It's a whole bunch, right? And I always picture a number line. In later videos, we'll discuss writing these out on a line notation. That's a whole other notation. But for now, just want you to picture the number line. And in the middle is 0, and it counts up to the right. Always counts up to the right. Just like in your coordinate plane, right? Except we're ignoring the vertical axis in this particular moment. And it counts down to the left, right? And what does it go to? Infinity. Infinity is not a number. It is a concept. It just keeps going on and on and on. The biggest number I can think of is Googleplex. It's going to hit that and it's going to keep going. That's what that arrow means. And that's what that symbol means. It's going to hit the biggest number you can think of and just keep multiplying it, keep going. Now, what happens when we go down? We keep getting lower. We get to negative infinity. Okay, that's a terrible infinity symbol. I'm going to draw that again. Negative infinity. Negative Googleplex. And then keep going. Keep going down, 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 down. Except we're going to the left. Always to the left. Always. That is important when writing interval notation, because when we write out x is greater than or equal to negative 3, let me draw lines here so that we remember which one goes with which. Oh man, running out of marker here. X is greater than or equal to negative 3. We start at negative 3. I'm going to have to remove this to give myself some room. We start at negative 3, right? And we go to the right because we're greater than negative 3. And what I always do with the inequalities is the inequality symbol is an alligator's mouth, and it's trying to eat the larger number. X, in this case, is a larger number than negative 3. But it could also eat the negative 3. That's what that means, the or equal to sign. So it's going from negative 3 to infinity. And we put parentheses whenever we do infinity. But if we're including the negative 3, we put a bracket. And that's just a different way of writing that. It's just a quick way. And it kind of helps you picture, like, okay, we're on the number line and we're going to the right. All the numbers to the right, which is all the bigger numbers. because inequalities, they could be written either way. I mean, this could be written -3 less than or equal to x. Same thing. But interval notation, order matters. -3 is on the left because it's a smaller number. It's brackets next to it because it's included, because it's an or equal to, comma, infinity symbol because we're going on forever, parentheses around the infinity. All right, let's do x is less than or equal to 7. Okay, we got 7, right? But now x is less than or equal to. So we're going the other direction. And we put our brackets around there because we're including the 7. And we have negative infinity, right? Because we're going down, down, down forever. Because we want all the numbers, the set of numbers that are all less than 7. All right. Now, what happens when we don't have an or equal to sign there? Well, start with 0 again. Greater than. So we're going this way. Always get parentheses on the infinity symbol, infinity side. But this is when we get parentheses next to the number because we're not including the 0. Brackets when we are including that number, parentheses when we're not including it. Always remember that. So you can guess what happens when we do x is less than 25. Start with 25 here. We're going down, right? Because we're less than negative 25, positive 25, and we're not including the 25. It's easy, right? All right, let's get a little more complicated. -3 is less than or equal to x is less than 5. Okay, so -3 is less than or equal to x, and x is less than 5. That's what I always think of. It's both x is greater than -3. See? It's the same thing we just did up here. -3 is less than or equal to x. And x is also less than 5. What does that mean? Well, we're going to have -3 here. And it's included because the alligators, I don't know what he's doing there, but he's going to make a U-turn and gobble up that -3 as well. And we have all those numbers in between, and then we go all the way to 5, and then we stop. But we don't eat the 5 because it's not or equal to, right? So it's just parentheses. And that is how you write that. No infinities on there because we don't go on forever. We're trapped in between these two numbers, right? All right, now I wanted to give you one like this. 4 is greater than or equal to x is greater than 2 because maybe your teacher somewhere might want to throw you a curveball just to see if you're paying attention. These symbols are reversed, just like I did up here. I reverse that symbol. We always think of the smaller number on the left, right? So why is the smaller number on the right? Because they're trying to confuse us. So if it helps you, you can always rewrite this with the smaller number on the left, but you have to remember to flip those signs as well, because that is what it really means. All the numbers from 2 to 4, including 4, but not including 2. I think you'll find that that is correct because x is greater than 2, right? Greater than 2. So it's going to the right. And it's less than or equal to 4, right? So going to the left of 4 and including the 4. All right. Now, all real numbers. Some teachers I've seen do the R with a circle around it. Others I've seen do a line next to an R, and maybe they include a little hat there. I don't know. It makes no sense to me. But the way you would write that in interval notation is if you wanted to include all real numbers, well, you'd start with negative infinity and go to positive infinity. And always remember, no brackets on infinity, because infinity is not a number. We're not including it. It's a concept. Because even when we reach infinity, we're going to go on to the next infinity. Not really, but yeah. All right, one last one. The or. This was an and statement. This is an or statement. This is the one that trips people up the most. X is less than 3. How do we write that? X is less than 3. Negative infinity, comma, 3, parentheses, because we're not including the 3, right? We're less than 3, so we're going to the left. So we include all those numbers, right? Or X is greater than 6, greater than or equal to 6. So we got 6 there, and we're greater than, so we're going to the right, right? So we need to have that infinity with the parentheses, but these are just two separate intervals, you know? They're not together really. So how do we do that? We have this symbol called union. And I call it union. I remember it's called union because it looks like a big U. It's a big horseshoe facing up. Make sense? So we would say all numbers less than 3 in union with all numbers greater than or equal to 6. And we skip all the numbers in between. We skip 3 through 5.9999 when repeating, right? Skip all those numbers. They're not included. For some reason, we didn't like 3 or any of the numbers between it and 5.9 repeating. All right, thank you for watching.